Hello my dear students, welcome back to our YouTube channel Diksha Vedantu Foundation. We are bringing here today with our second day of midterm score booster series of mathematics, and the chapter for the discussion is polynomials. What we're going to do today is we're going to discuss all the possible questions starting from the very basic, the questions based on definitions, and we'll go ahead with increasing the level of the questions up to the questions which are coming, which are expected in your upcoming examinations, which have already come in the examinations and which are expected to be coming in your examination. Also very important chapter. Why? Because this is a chapter from where algebra starts. Okay, and you know, if you are in mathematics, you'll always have some or important part of algebra to deal with. So very important to focus in the session, learn your basics, learn your lessons, and solve all the questions with me today. So do one thing, take your pen and paper out, be with me till the end of the video, solve all the questions. Also, as you know, at the end of the session you'll have homework questions to solve. I have given some questions based upon the session today. I know you will all solve it. Let's just start with our session. I'm very sure after this session you'll all be very happy with the chapter and you are glad that, okay sir, I understood every single topic that you have done, every single question that you have explained, and we are gonna be very prepared for this chapter coming in your midterm examination. Let's begin with our video. So the first session, the first slide over here is based on the definition. Very basic. What is a polynomial? So a polynomial is what? It's an algebraic expression which has both constants and variables in it. Sir, what is algebraic expression? Same thing, any constants and variable arranged with mathematical operation. Sir, what type of mathematical operation? What are the mathematical operations that we know? We know positive sign, we know negative sign, we know multiplication, we know division. So using all these four mathematical operations, if you have constants and variable arranged in a mathematical statement, that is called as algebraic expression and polynomials. Okay, now we'll learn about today in the session for what expressions we cannot call polynomials and for what expressions we can call polynomials. So I've taken some examples. Let's get to them one by one. So the question is, sir, how is 2 a polynomial? I said not only constants, not only variables, we also have combination of constants and variable, and we also have just constants, just variables. Even if these situations are present, we'll call the expression to be polynomials. So in this case, as you see, just constant, true, it is a polynomial. Next example, 2x plus 2, both constants and polynomials with the mathematical operation, which is what here? Positive sign. Okay, addition is present. Second one, 2x plus 2x plus 2. In this situation, what happens? The number of terms has been increased to 2. So if you look at these three examples, there is certain type of variation. First had only one term, second had two term, third had three term. Any other type of variations you can see? Yes sir, I can see. First is just a constant term. Second is the degree, the power of the variable x is only 1, sir. Whereas in this case we have an example where both the degrees are, both the powers is present, 2x power 2 and 2x power 1. Glad you noticed, because what is the next topic of ours is how we classify polynomials on the basis of which called categories. So the categories that we have here is on the basis of degree and on the basis of number of terms. Okay, so how many terms are present, on that basis we will define a polynomial, and on the basis of what is the degree of the polynomial, we'll define a polynomial again. So these are the classifications that we have. Now some people might have forgotten what is the degree, so I'll just define it quickly so that you'll have the recollection. What's the degree? Degree is the highest power of the variable in any given algebraic expression. In any given algebraic expression, whatever is the highest power, highest index of the variable, that part is called our degree. So if we take the same example here, what is written? 2x square plus 2x plus 2. Now you only tell me, what are the exponents, what are the powers available for our variable? We have only two situations. Over here the index is just 1, index is 2, the power is 2, means what is the highest value of this power? Obviously 2. So this 2 will be called the degree of the polynomial or degree of the algebraic expression. Understood? Okay guys, one announcement here. If you would like to let's say while doing the classes, you might not remember everything at the end of the video. You want to know some things, you want to recall things again, you can go to this link, go to this page, download your PDFs from here for the lecture that has been conducted. So this lecture will be conducted every day. You can download your class notes from this page. Visit the link given in description. I hope it's clear. Excellent. So don't forget to do that. Make sure that you revise the notes after your class, because what happens, whenever you have, let's say, attended a lecture, any lecture you have attended, and you just leave it like that, then you will not remember. Human mind cannot remember everything that it has learnt or heard, right? So what you can do is, if you on the same day, right after the class, go ahead and read the notes, then you will have better memory or better memory recollections coming from the class. So you have given some time to watch the video. If you don't benefit from it, then what is the point? So make sure that you download the PDFs and do the questions again, because the goal is to score very good marks in our coming midterm examination, right? Let's move on. Now we'll take some examples, and because what happens, this kind of question is asked, they'll give you which of the following is not a polynomial directly. So without knowing those examples, how will you know? So actually, to summarize all of these cases, I've written one line behind or below the title. See it? Variables power is whole number. If you remember the statement, any question that comes on this kind, like what are the expressions given is polynomial, and whether they are polynomial or not, you can answer without doing any hard work. Just remember this statement. The variables power has to be always whole number. So whole number, it means it can be 0 also. Yes, it can be 0 also. We just looked at expression, no? We said 2 is a polynomial. So there is no variable here. Then why are you saying variables power can be 0 also? I can write this 2 as 2 times of x to the power 0. Sir, how? Because 2 times of x to the power 0 is nothing but 2 times of 1. And any number can be written as the number itself multiplied with 1. So you can see here, I have a case where the degree is 0 and still we have what? That as expression, that as polynomial. Pardon me. So variables power can be a whole number. Is that clear? Okay. Now let's take some examples where those expressions are not polynomials. Okay. So let me write it. This expression, this polynomial. Okay, how do I write a polynomial? How do I name a polynomial? I can write a bacha px. You have learnt in grade 9, no? So this is a polynomial in which variable? X. So I can write px equals to root 3x square plus 5x plus 6x cube minus 9. Now the question is whether this is a polynomial or not. Okay, and second question, if it is a polynomial, then what is the degree? Okay, so let's see. What did I say? Sir, power has to be whole number. Check wherever is the variable, check their power. Variable x power is 2. Variable x power is 1. Variable x power is 3. So yes, it's satisfied, means this expression is a polynomial. Now what is the degree of this polynomial? Degree is what? Degree is highest value on the polynomial, which is 3. Okay, now let me write some expression which is not a polynomial. Let's check. So px equals to, what if I write like this? Root 3x plus 2. Is this a polynomial? Sir, you said only one thing. Look for the power of whole number on the variable, that's all. But there is no power. The power, if you look at x, is 1. Then why it is not a polynomial if you have given example of not a polynomial? Because any root, whether it is square root, whether it is cube root, whether it is ninth root, How do we write those roots as in terms of indexes, in terms of powers? Square root can be written as something to the power. If let's say I have x here, if I have, let me take another variable. Let's take another variable. Okay, so let's take here y. So we are finding square root of y, cube root of y, ninth root of y. What it actually means is y to the power. Square root means 1 by 2. For cube root, what it means? Y to the power 1 by 3. For ninth root, what it means? Y to the power 1 by 9. Look, I'm taking time in this slide because a lot of people miss these parts. I know your teachers must have taught this, but you miss it. You know, students, no, you can make some mistakes. So it's my job to make sure that I give the content which will help you ultimately. Okay, so yes, square root can be written as 1 by 2, cube root is written as 1 by 3, and ninth root can be written as 1 by 9. For that reason, I can write this expression as what? I can take the root 3 part separately and write root x part separately plus 2, and this will become root 3 times x power what? 1 by 2, because root is 1 by 2. So x power 1 by 2 plus 2. 1 by 2 plus 2. Now you only tell me, does this expression satisfy our definition? Power is whole number. Is the number 1 by 2 a whole number? Can you see this as whole number? 1 by 2? It's a fraction. It's not a whole number. It's a decimal 0.5. Then how can it be a whole number? It means this statement that we have written here cannot satisfy the example of or a case of whole numbers. So whenever you see any expression with power, root, or which x is inside the root, okay, what about I have written here root of x power 4. Don't say it is not a polynomial, sir. Root of x power 4 is what? X square, right? So if the root is not solvable, if you cannot simplify it in terms of whole number, then only those expressions will become your polynomials. Like those expressions which we cannot simplify will become like category where this cannot be called as polynomial. Whenever you can simplify the roots, it will be polynomial. Basic understanding: whole number power, polynomial. If there is no whole number, fraction is present, whatever else, you will take it as a statement or example of which are the things which are not polynomials. Okay, let's continue to our next slide. I think we have given enough time for the last slide. Excellent. Now the classification, I gave a brief, right? Classification of polynomials on the basis of number of terms, sir. So whenever we have one term in the polynomial, that is called as monomial. Whether the term is constant, whether the term is variable and constant, whether the degree is 1, degree is 2, degree is 100, does not matter. Only thing that matters is number of terms. Check it out here. 2, just constant. 2x, constant and variable. 5y square, constant, variable and a power. Does not matter. Only thing that matters is only one term. What about binomial? 2 terms. Bi means 2, mono means 1. So bi means 2 terms. It should have 2 terms in it. How are the 2 terms? Doesn't matter. X plus 2, 2x cube plus x power 5. Okay, but there should be a polynomial. The power has to be whole number. That matters. Okay. Trinomial. What is trinomial? Name suggests tri means 3. Okay, this is enough. Next we have biquadratic. We have polynomials. We generalize it as polynomials, but these 3 are enough for your upcoming examination. Okay, for 4 we call it as, okay, so anything after 3 we call it as polynomial as general. Okay, let's see what is for 4. 3 terms we have 3, no? X minus x square plus 8 minus x power 5 x power 4. These are 3 terms in the same statement, that is trinomial. Let's move on. So over here we're gonna start with classification on the basis of degree. Okay, this is very important. This comes directly in your MCQs. Okay, if you don't know the definitions right, you might make mistakes and lose marks. Very free marks, because they are very easy, just conceptual part. So be with me, focus, pay your attention here. Okay, so classification on the basis of degree. First one, constant polynomial. Sir, you said constant polynomial are just the polynomial with constant. Then why is the degree informed there? So if I'm writing just 2, or just writing just 1795, yes, they are constant, but how the degree matters here? Because I said right now in the example also, I can write 1795 as 1795 into 1, and this will become 1795. 1 can be written as x to the power 0. So any number can be written as multiple of 1, and then 1 becomes x to the power 0. What is the degree here? What is the degree here? Check. The degree here is 0. So whenever the degree is 0, that is called as constant polynomial. Excellent. Excellent. Next part, linear polynomial. What's the degree? 1. Whenever we have degree as 1, that is called a linear polynomial. Means I can take an example. P plus 1. What's the degree of P? Just 1. T plus 5. Degree is just 1. 5x plus 2. Degree is 1. Means on the variables written there, x, t, p, what is the highest power? 1. Quadratic polynomial. Very important. Actually, your entire chapter will be based on this only. Okay. So a lot of questions will come from quadratic. So understand it in a very simple way. Degree is 2. Degree is 2. Means the variable will be written as s square minus 4. Will be written as x square plus 5x minus 2. All these are possibilities. Okay. We can be written as y square minus y. So all these, whether they are just constants, just variables, constants and variables, all the combination, but highest degree should be only 2. Check it out here. S to the power 2, x to the power 2, y to the power 2. So highest degree or highest exponent of the variable is 2. Excellent. Okay, cubic polynomial, as the name suggests, degree is 3. Examples, take x cube minus x, x cube minus 2x square plus x minus 2. All these, whenever the highest power is 3, is cubic polynomial. Now this big brother, 0 polynomial, looks insignificant. 0. What is 0 polynomial? What is 0 polynomial? So 0 polynomial is a polynomial which has only one term. It is not a group of polynomials. So for a constant polynomial, I can write 2, I can write 5, I can write any number. But for 0 polynomial, I have only one single, which is big 0. So 0 is called as 0 polynomial. Okay. Now, sir, what is the degree of 0 polynomial? Answer is not defined. Not defined. Now, if I just write like that, 0 polynomial is 0 and degree is not defined, many of you will go in the examination and write, if they have option given, degree of 0 polynomial 1, 2, 0 not defined, you will tick 0 and come. If you remember, you will write. If you forgot, if your logic has to work, you will say 0 polynomial degree is 0, tick, get 0 marks. If it's a competitive exam, get -1. Very happy. Okay, let's understand why it is not defined. Okay, so how can I write 0? I can write 0 as 0 into 1. 1 can be written as 0 into x to the power 0. Yes, sir, the degree, the power is 0. So the degree is what? The degree is 0. I'm right. You said if I write degree as 0, it is incorrect. But I can also write this 0 into 1 as 0 into x to the power 1000. Why, sir? Because x power anything multiplied with 0 is what? 0. So it does not matter. The second term multiplied with 0 has no significance at all, because it will make it 0. So we will not know what exactly is the degree, whether it is 1000, whether it is 1, whether it is 5, whether it is 5000. We don't know. So there is no certain way to define a degree for a 0 polynomial, because the second part makes or becomes insignificant. For that reason, we call the degree of 0 polynomial to be not defined. Hope from here onwards you will not write or tick the question as degree of 0 polynomial as 0. Understood? Great. Let's move on to the next slide. What is the value of a polynomial? Simple. What is the value of anything? Means, let's say I have taken a simple question, 5x plus 2. Let's quickly ask, what is that polynomial? Degree is 1, linear polynomial. So value of a polynomial is nothing but for any given x, what will come out of the polynomial? Okay, let's take an example and simplify it. So for any x, I can take x to be, any real number I can take, no? I can take any real number, I can take irrational, I can take rational, I can take decimal, anything. Any real number is okay, right? So x, let's take, I take 0. If x is 0, bhaiya, what will this become? What will the polynomial become? 5 times of 0 plus 2. Answer is 2. Sir, why I have not written anything in next up to the polynomial? Because I'm gonna write there 0. Sir, why you are writing 0 there? Because we have changed this x with what? 0. So value of the polynomial whenever we are finding will replace that x value instead of x written here in the px or in the definition or the name of the polynomial. So we are finding polynomial at 0, that's why I write p0. If I write p2, how will I write p2? Sir, wherever is x, replace it with 2 and you will get p2. Answer is 10 plus 2, which is nothing but 12. Easy. Let's try with, what is this? Quadratic. Sir, how? Degree is 2. If the degree is 2, it's quadratic, right? Excellent. This was linear, this is quadratic. What I'm going to do? Sir, take x equal to 0 only. Very simple, we'll take p of 0. What will this become? How we do it? Wherever is x, replace it with 0. So 0 square minus 0 plus 2, answer is 2. Take x as some number. Let's take x as 2. What will this become? 2 square minus 2 plus 2. Answer is 4 minus 2 plus 2, which is nothing but just 4. So value of the polynomial is nothing but take any x given, replace the x from the expression as the number, whatever you have any real number as, and whatever comes out, the outcome of that will be the value of the polynomial. Very clear? Very simple? Nothing much to do there. Now this is something important to understand. 0 of a polynomial. What is 0 of a polynomial? So one of those values, we learned right now what is the value of the polynomial, right? So out of one of those values, we'll call that value to be 0. Sir, but what that value will be? Is there any significant definition of it? Of course, yes. So any particular value of a real number, when put in place of x, makes this expression 0. Means, what can I replace x with? What can I write x as? So after writing x, this whole thing should become equal to 0. Okay, how will I write that? So I know the answer, I can write it. I'll write it as minus 2 by 5. Sir, how do you find that? How do you find that? Nothing, very simple. Take the expression 5x plus 2. What is the end goal? End goal is to make it equal to 0. Means whatever is x, it should make it equal to 0. So we're gonna take here equal to 0. We are assuming, let's say this x here is making this expression 0. Now solve the linear equation. 5x equals to minus 2, x equals to minus 2 by 5. Our answer is known now. I wrote here minus 2 by 5. Very difficult? No, right? So for linear equations, for linear expressions, linear polynomial, this is how we find 0. What about quadratic? The definition remains same. The definition remains exactly the same. What was the definition? For what certain value of x out of the real number, this expression, this polynomial, whether it is quadratic, linear or cubic, it should become equal to 0. So we'll do the same thing. We'll write this expression equal to 0. Sir, how will you solve it? Don't say that. Factorization. We have solved this. Split the middle term we have used, right? So same thing we're going to use here. Check it out. Let's do the split the middle term for this. What we used to do for the split the middle term? Multiply the first and third term. Sir, any first and third term is okay? No. There's a standard format of quadratic polynomial, no? We write the highest degree first, then the linear term, which is x, then the constant. So we will multiply what? Constant with the square term. Okay? Not first and third. Anything which is given, you arrange it in this format. First, multiply the constant term with the sign to the square term. So what we get here is minus 2x square. What next? Write factors of 2. Factors of 2 is what? Just 2 and 1. It's a prime number, right? 2 is a prime number. How can we write? Now, using 2 and 1, can you get just what? It is 1x, no? I can get, sir. Take 2 positive and take 1 negative. 2 minus 1 is 1. Now, take this, write x on both the places. So, 2x minus 1x. What we have done? We have split this 1x as 2x minus 1x. Let's see how. We can write this as x square plus 2x minus 1x minus 2 and what? Equal to 0. Why equal to 0? Because that is what we are doing. We are trying to make the polynomial 0, but with what x? We are trying to reach that x by making the polynomial equal to 0. Is it right? 2x minus 1x is 1x? Correct. Let's simplify, club these two terms together and take whatever is common. What's common in the first one? X is common. So x plus 2. Second one, what is the common? Just negative sign, right? So take the negative sign common. Nothing is there, remains 1 is there. X plus 2 equals to 0. Okay. What is common now? How many terms we have? 2 terms. Term number 1, term number 2. What is common? X plus 2 is common. Take x plus 2 common. What we have left? X in the first term. Second term, here x is left, right? Check. And from the first term, if I take x plus 2 common, x is left. Second term, what is left? Minus 1 is left. So what can I write here? X minus 1. X minus 1. So my factors have become x plus 2 times x minus 1 equal to 0. Now think. Okay, I'll write it over here. I will write it over here. So x plus 2 times x minus 1 is equal to 0. Same thing I've written here. Now how can the product of two numbers become equal to 0? If one of the number is actually 0. Two numbers multiplied is equal to 0. Is it possible? Any other case then the number has to be 0, one of the number. So let's take in the first case x plus 2 as 0. What is it? X plus 2 equal to 0. It means x equals to minus 2. X equals to minus 2. Not clear, I guess. Let's erase this part and write again. X equals to minus 2. So whenever x is minus 2, the first expression will become 0. What about second one? X minus 1 equals to 0, and this will give me x equals to 1. So we have two zeros of the quadratic expression, quadratic polynomial given here. When we did what? We equated this with 0. Right? What we have done? Solve the split the middle term, and we got two zeros of this polynomial as 2 and minus 2 and 1. Let me write it here. Minus 2 comma 1. Okay. Now there is one point to note here. Okay. What is that point? That for linear polynomial we had only one zero. We had only one zero, minus 2 by 5. But for quadratic polynomial we have how many zeros? We have 2. We have 2, minus 2 and 1. What for cubic? We'll have 3. Okay. But is it always the case? No. we'll have maximum of 2, maximum of 3, and it goes like that. Okay, so for any, let's say for any polynomial, we want to find out how many degrees exist, pardon me, how many zeros exist for that polynomial. That will be from where? The degree you look at. The degree is 3, maximum of 3 it will be. Degree is 4, maximum of 4 it will be. So number of zeros of any polynomial will not exceed the degree of the polynomial. That's the upper limit. Okay, great. Let's move on to the next part. That's what the first statement is. Number of zeros of the polynomial cannot exceed the degree of the polynomial. It means if I have the highest degree as, let's say, 10, how many values will exist for this polynomial? Zeros. 10. Okay, maximum of 10. Okay, so I'll have some other terms written here, whatever it is. If I have cubic polynomial, x cube minus x plus x square plus 2. For this polynomial, how many will exist? 3, because degree is 3. Excellent. Now last one, constant polynomial does not have a zero. Makes sense? Write a constant polynomial 2. Write px equals to 2. So yx, I can write here, no? X power 0. Okay, for what value of x this will be 0? Tell me. What can you replace x with to make this expression 0? Anything you take as x, the power is 0, right? If I take 2, 2 power 0 is how much? 1. So 2 into 1 will be 2. So for none of the value of x, there isn't actually x. For any constant polynomial, there is no 0. No 0 for a constant polynomial. Simple. Let's move on. Okay. Now, geometrical meaning of zeros of a polynomial. So what it actually means geometrically. So on the graph, if we are analyzing any linear, quadratic or cubic polynomial, what it actually means, that 0 of a polynomial is something. Okay, so geometrically what it means, what was the definition? Whenever the outcome of the polynomial is 0, right? That's what I said. The outcome is 0, then that value of x which makes the outcome 0 becomes the 0 of the polynomial, right? So if you remember, what is this? This is our linear expression. If I have to write a linear equation, how will I write? Y equals to x plus 2. We have learnt grade 9 linear equation, we have learnt, no? Y equal to x plus 2. What did I say right now? Outcome becomes equal to 0. What is the outcome of x plus 2? Y. Y is the outcome, no? I put x as 1. What is y? What is this 3? This 3 is nothing but my y value. So whenever the outcome is 0 means what? Whenever the y coordinate is 0. When that happens, whenever the y is 0, we'll call that to be, that x to be 0. In this case, what is it, sir? What is this in this case? X plus 2. So whenever x is minus 2, I will get y as 0, right? Because minus 2 plus 2 will make 0. So minus 2 plus 2 makes 0. Outcome is 0. It means x equals to minus 2 is the 0 of the polynomial given here, x plus 2. This is the definition. This is what we learned so far. Now graphical part. Y equal to 0 means what? What is the meaning of y equal to 0? Y equal to 0, if you have learned coordinates, okay, y equal to 0 is nothing but a line. What line? X-axis. Forgot. X-axis is my y equal to 0 line. Any point I take, let's say minus 15, okay, plus 15, any point I take. What is the next coordinate? Y coordinate here, comma 0. Over here, comma 0. So any point, there are infinite number of points on x-axis. For all these points, what's the y coordinate? 0. That's why x-axis is also called as the equation with y equal to 0 expression. Okay, so whenever the equation is y equal to 0, that is called as x-axis. Now, so basically whenever any given polynomial's curve, any expression will have a curve, right? Will have a graph, right? X plus 2 is what type of graph? A line graph, it's a linear curve. So line graph, whenever it is drawn on a coordinate axis, wherever it touches x-axis, that point will be called as 0. How will I draw x plus 2? How will I draw x plus 2? Y equal to x plus 2, how will I draw? You have learnt it, right? Right here. Take x as 0. What is y? Pardon me. I took y as 0. So take x as 0. What is y? 2. Take x as 1. What is y? 3. We have 2 points. 2 points are enough to make a what? A straight line. Okay. Take y as 0 now. This case. Y as 0. X will be minus 2. Let's plot these points. 2 comma 0. Where is 2 comma 0? 2 comma 0 will be, sorry, not 2 comma 0, 0 comma 2, right? Because first we write x, no? So 0 comma 2. 0 comma 2 is somewhere here. 0 comma 2. Next 3 comma 1. 3 comma 1 will be where? 3 comma, okay, x is 0, y is 2, correct? 3 comma 1, 1 comma 3. My bad, I am reading it again, ulta. 1 comma 3. When I have 1, okay, and where is 3? 3 is here, somewhere here, right? 1 comma 3. Okay, next will be what? Minus 2 comma 0. Sorry students, I read y first. What is the coordinate value? Always read x first. Okay, so x is minus 2, y is 0. So minus 2 comma 0 will be somewhere where? Somewhere, let me erase this part. This is not relevant for us. Minus 2 comma 0. Let me write it here. Minus 2 comma 0. So the line which will go through this will be something like this. Let's say, okay, I'll erase this, and this is my point 1 comma 3. Okay, so now if you look at this line which is going like this, wherever it cuts the x-axis, and that point x coordinate is what? Minus 2 is called as 0 of the polynomial. So what is the graphical representation? What is the value of x when the graph cuts x-axis? Okay, let's take another example and understand this. This time it's quadratic. X square plus x minus 2. I think we just solved it. Did we solve it? X square plus x minus 2. Yes. What are the roots? What are the factor? X plus 2, x minus 1. X plus 2, x minus 1. Right? We just solved it. X plus 2 and x minus 1. When you plot this graph, Acha, one thing you understand here, this is important to know, that for a quadratic equation, or right now we are not into equations, we are into the polynomials. For a quadratic polynomial, the graph is always a U-shaped graph. A U-shaped graph. And this graph is called as parabola. What is it called as? Parabola. You learn in very much depth in grade 11th. Okay, a conic section is a chapter which will come in your grade 11th, where you learn parabola and its properties and its definition and more questions on it in very much depth. Okay, for now you just remember, for quadratic polynomial or quadratic function, the graph is always U-shaped graph, parabola. It can be like this or it can be like this also. Inverted is also true. Okay, inverted is also true. So let me erase this for now. So this curve will look like this. So if x is 0, what is y? Just check this. Just quickly find me this value, p of 0. It is 0 plus 0 minus 2. Means what is this value? Minus 2. Means when x is 0, y is minus 2. How y, sir? Because as I just told you, right, this equals to y x square plus x minus 2. So when x is 0, y is what? Minus 2 only, no? So which will be this point? Over here, check. X is 0 and y is minus 2. What about the x values over here? If you equate it with 0, my x values are minus 2 and plus 1, right? So this, where is minus 2? Minus 2 is somewhere here and plus 1 is somewhere here. So I'll write this as 1 comma 0 and this as minus 2 comma 0. Why this? Why 0? Because any point on x-axis will have y coordinate as 0. We just learned right now, na? And we'll just complete this curve like this. This is my parabola, the u curve, for which function? X square plus x minus 2, right? X square plus x minus 2. The graph going from which point? These 3 points. Now come back to the what we learned in the graphical meaning of the zeros. Wherever the curve of the polynomial or the graph of the polynomial cuts the x-axis, okay, that is my 0. The x coordinate is my 0. What is the x coordinate over here? X equals to minus 2, x equals to plus 1. Now some people might have this doubt. Sir, you already found it. Then why are you doing this again? Bacha, this will not be given. We don't have to do this. The graph will be given. For me to draw this graph, no, I took this like that. For me to draw this graph, I took this way to solve the zeros and come to this point. But actually, in the given cases, in the question which will come for examination or any place you see, will be based on only graph. The graph will be given. So by looking at the graph, what we can say? The zeros are minus 2 and plus 1, right? So we don't have to do this part, just this will be enough. I just did it to plot the graph. I hope this is clear, okay? You don't have to do the dual work. Only one part is enough. If the graphical part is there, the only graph will be given. Find the zeros. For the algebraic part, you know the steps. Let's move on to the next set. Okay, let's move on to the next slide. Over here. So now we have actually 3 cases. I just said no, the graph will be given. So now we have 3 cases of such situations where what polynomial? Only quadratic, okay sir? No. We can take any polynomial, bacha. Any polynomial, linear, quadratic, cubic, any type of polynomial we can take and we can answer that question using the graphical method that we learned, okay? Wherever, what is the method? Wherever it cuts x-axis, that is the 0. Which is the 0? X coordinate is the 0, okay? So why only quadratics we are taking, sir? Just to understand our concept, okay? Not necessarily we can use cubic also. Actually, the question that I've taken is on cubic only. For right now, to understand, we have taken polynomials which is of quadratic nature, okay? So if you look at case 1, how many points it is cutting? The x-axis, 2 points, 0.1 and 0.2, 0.1 and 0.2. I don't think it's visible. Let me take this. So 0.1 and 0.2. What are those 2 points? Actually, they are written as A and A dash. So let's say this value is 2 and this value is 5. So my zeros are nothing but x equals to 2 and x equals to 5. So whenever the x-axis is cut by the graph, 2 places will have 2 zeros. Okay, this is clear. Let's move on to the case number 2. In this case, what is happening here? Check this out. How many cuts? 2, only 1. Only 1. Let's say this value is just 2. So x equals to 2 is the only one zero of this given case of the polynomial. Next, here, how many zeros? No zeros. So, no zeros. What it means, sir? It does not cut x-axis only. It's going from here. There's no x-axis involved here. There is no cut on x-axis. Then how can we say there is a 0? So for this situation, where the graph does not cut x-axis, we'll have no zeros for the given polynomial. Let's continue. I said no, I have taken cubic example. Take this. Look at here. What is it? It's not a curve of, it looks like parabola, but it is not a parabola because it is 2 part, no? See, this part and this part. So it is actually a curve of cubic polynomial. Again, you will learn very in detail in your 11th grade. Okay. For now, we'll focus only for the graphical part. How many parts it cuts? How many points it cut the x-axis? Point number 1 and point number 2. Let's call these values to be anything -5 plus 5. -5 plus 5. So what are the zeros? X equals to -5 and plus 5 are the zeros of the polynomial. So you said there are 3 for the cubic polynomial. Why only 2? I said maximum of 3. Good that this question came. Maximum of 3. 2 is okay. But we cannot have 4. We cannot have 4 zeros. We can have only 3 or less. Sir, but how? Because bacha, actually over here we can also say that there are 2 zeros. means one of the other 0 is 5. But then you'll say how, why, not important for us, so I will not write that part. I'll erase the last part. For now, what is the important thing? How many parts it cuts? 2 points it cuts the x-axis to 2 zeros. One more thing that we learnt, we cannot have more than 3 zeros because it is an example of cubic polynomial. That's why we cannot have more than 3. So let me erase the last part that I written here. Okay, very good, very good. Maintain the energy, be with me. I know the session is going longer, but I'm trying to cover up everything. Okay, so after looking at this video, because the thing is, this is the time which is right across your midterm examination. You cannot watch too many videos. Okay, so I'm trying to come with a video which, if you watch, if you give your time to it, you should be able to understand every single thing which is there in the chapter. So that's why the videos are a little longer. Okay, so make sure you should not watch all the resources. Come here, watch the video, learn everything, and be ready for your examination. Okay, come on. The next part, very good question actually. So easy, extremely easy, but a very like you have to use your brain in this question. Use the logic, okay, which I know you guys like to use. The graph of quadratic polynomial px passes through the point -2, 0, 0, -6, 2, -3, and 2, 0. Okay, sir, what you did? I couldn't even understand. So let's break the question. What is the question breaking? -2, 0, 0, -6, 2, -3, and 2, 0. What have they given us? What have they given us? They have given us 4 coordinates. They have given us 4 coordinates. Simple. Write the coordinates on the Cartesian plane. What is the Cartesian plane? XY axis. X is here and Y is here. -2, 0. Where is it, sir? -2, 0 will be somewhere here, sir. -2, 0. Next what, sir? 0, -6. X is 0, Y is negative. Where, sir? Here, sir. 0, -6. Okay. 2, -3. X positive, Y negative. So somewhere here. Right? Now what about next one? 2, 0. So over here, sir. 2, 0. A graph which should go through all the 4 points. Let's see. देख लेते हैं. Let's see. So a graph of a polynomial which should go through all these points. Arey, draw a graph, no? Sir, why only parabola? Why only you took? They have mentioned, bacha. Read the question. They have mentioned a quadratic polynomial. That's why I have taken only u. I have not taken anything else, right? So what is this point? I forgot to mention. What is this point? 2, -3. So what they give in the question, whatever they have given, I have drawn on the curve. Now what is their question? The question is, find the zeros of the polynomial. What we learned? Wherever it cuts x-axis, take the x coordinate of that point, that is the 0. X coordinate of this point, x equal to -2. X coordinate of this point, x equal to 2. Why this point? Because that's where the graph cuts the x-axis. So the roots are x equals to -2 and 2. Why 2 roots? Because it's a quadratic polynomial. It can have maximum of 2 roots. Easy. Easy or not? We have to think, but not difficult. Thinking is good, right? It develops us. Next, one of the 0 of quadratic polynomial. Okay, now coming back to algebraic methods. Graphs, we had fun in graphs, but now coming back to algebraic methods. What have they have done? They have given us a polynomial. They have given us a polynomial. K minus 1 x square plus kx plus 1. And they have given us also one of the 0. So let's write the polynomial. Can I write the polynomial? Let's name it. It does not have a name, right? Let's give a name. What is the name of the polynomial? Sir, fx we used to learn in grade 9. Take fx, sir. Okay, fx equals to k minus 1 x square plus kx plus 1 plus 1. Now 0 is given. What do we know about 0? 0 is that value of x, sir, which makes the polynomial equal to 0. the outcome equal to 0. So I can say that on using this value minus 3 as x, so I can say that if x is equal to minus 3, then f of minus 3 will be 0. F of 3 minus 3 will be 0. Then let's do that without wasting time. F of minus 3, f of minus 3, f of minus 3. What it means? Wherever is x, replace it with minus 3. Chaliye, let's do it. K minus 1. Will I replace k? No, only x. Okay. So minus 3 square plus k times of minus 3 plus 1. Sir, how do you solve this question from here on? I wrote here minus 3 is equal to 0. F of minus 3 equal to 0. Replace this with 0. Now you can solve this quadratic equation. K minus 1, sorry, linear, not quadratic. It's a linear equation, okay? Why linear? Only one variable k. What's the power of the variable? 1. So linear. So k minus 1 times 9 minus 3k plus 1. I hope you know the multiplications, right? Yes. What is this? 9k minus 9 minus 3k plus 1. Simplify it, come on. 9k minus 3k, how much is that? 6k, sir. It is 6k. Minus 9 plus 1, how much is that? Pardon me, it is negative, right? I made a mistake. Excellent. Okay, so minus 9 plus 1 is minus 8. Bring the constants on one side, variables keep on one side. So it will become 8. Why 8? Negative comes here, becomes positive. 8 by 6 equals to k. Simplify this k. We get k as 4 by 3. And this is my answer for k. Find k. K is equal to 4 by 3. Question done. Very easy. What we did? Nothing. X equal to minus 3 they gave. The 0. Put in the expression in the polynomial. We know it is going to be outcome. It's going to give the outcome as 0. We have taken the outcome as 0. Simplified the linear equation. Solve the linear equation. K is 4 by 3. Done. Move on. Come on. If the 0 of quadratic polynomials x square plus, okay, now they have taken quadratic polynomial and they have given two zeros. Also they have given two variables. If you remember your teachers telling you, I know you will not remember because your teachers tell you a lot of things, but why will I listen, sir? Because what they say is important. They are saying for your benefits. Okay, so what did their teachers have told you? They might have told you, they should have told you that if I have to find two unknowns in an equation, there are two unknowns variables in an equation, I need two set of equations. If I have to find one unknown in the equation, I need only one equation. So how many unknowns are here? Two unknowns are here, sir, A and B. Two unknowns are here, sir, A and B. So I will need how many equations? Two equations. To form the two equations, they have given us two values of zeros, 2 and minus 3. So let's use 2 ones to get one equation, and let's use minus 3 ones to get another equation, and we'll solve the two equations to get our final answer. Come on, sir, maintain the energy. Okay, first one, what is it? What is it, bhaiya? It is the polynomial. Let's name it first. Give a name. Why to keep this guy unnamed? So fx equals to x square plus a plus 1 times of x plus b. Have I missed anything? I do not think so, right? Signs are all good. X square plus a plus 1 plus x plus b. Okay, I am also human, can make a mistake. So be with me, bear with me. I'll try to make the minimum mistakes ever possible, but I might also make a mistake. But I have not made any mistake in this case. So there's all of these signs are positive. Now what we are going to do, as I said, take one of the 0 at a time. So f of 2 I'm going to take. What happens if f of 2? Nobody will say miss now. 2 is a 0, means f of 2 is 0. I will not write that separately. Now I want you to know 2 is a 0 of the polynomial, means f of 2 is equal to 0. I'll use it next step. Okay, let's use. What does f of 2 means? Replace x with 2. So I'll write this as 2 square plus a plus 1 times 2 plus b. F of 2 is equal to what? 0. Why? Because 2 is a 0. 4 plus 2a plus 2 plus b. Excellent. What it means? Constants on one side, variables on one side. कर लेंगे. 4 plus 2 is 6. 4 plus 2 is 6, right, sir? 6 is positive. Bring on the left hand side of the equation becomes negative. I will write directly here minus 6 equals to 2a plus b. Sir, how minus 6? 4 plus 2 is 6. 6 is positive on the RHS. Bring on left hand side becomes minus 6. Okay, this is my equation number 1. So why equation number 1? I just said two unknowns a and b. I need two equations. Second equation will come from where? Minus 3. Will come from minus 3. I'll take from where, sir? From the same polynomial. We'll write this time f of minus 3. Correct? F of minus 3 we can write. Okay. Chaliye. So f of minus 3 will be what? Same thing we'll do in this expression. It'll be, so in this only, we'll put x as minus 3. So x minus 3 square is how much? 9 it is. We can write it next step. A plus 1 times minus 3. I'm writing all the steps, bacha, so you'll understand everything. You should not have any confusion. Okay? Plus b. What is going to be? 0 directly, because minus 3 is a 0. 9 minus 3a minus 3. How? Multiply. Multiply. Minus 3 with positive of a will give me minus 3a. Multiply minus 3 with positive of 1 will give me minus 3 and plus b. Okay? Okay. Now 9 minus 3 is how much? This 9 and minus 3 is how much? 6. It is a 6. 6 is positive or negative? Positive. Bring on the left hand side becomes minus 6 equals to minus 3 plus b. Minus 3a plus b. What we have done? Constants on one side, variables on one side. This is my equation number 2. Equation number 2. Should I highlight it? Should I highlight it? Okay, let me highlight it. Because a lot of things are written on the board. You might not see everything. Okay. Can you see it? These two are my equations. Is it highlighted enough? Okay. Let's come back to working. Now do one thing. Okay. I have to switch back to pen. Okay. It's pen and it's yellow. Let's go. Now do one thing. Do equation 1 minus 2. Do equation 1 minus equation 2. What will happen? Let's write equation 1 first. Minus 6 equals to 2a plus b, and equation 2 minus 6 equals to minus 3a plus b. Subtraction means sign change. Subtraction means sign change. Plus, plus, minus. I don't have to say that, you all know, right? Minus plus gets cancelled. What is the answer here? 0. 3a plus 2a, 5a. Why? Becomes positive on subtraction. And this plus minus gets cancelled. So what is my a value? 0 by 5, which is a 0. 0 by 5 is a 0. Now take any equation. Take equation 1. Minus 6 equals to 2a plus b. A is 0. So minus 6 equals to 0 plus b. So what is b equals to? Minus 6. I hope you understand. What is the answer for a and b? What is the answer for a and b? A is 0, b is minus 6. A is 0, b is minus 6. Clear? Clear? Okay. Okay? Nothing what we did. We used the zeros, got the two equations, linear equations. We solved them to get the answer. आगे बढ़ते हैं. Let's move on. Now in detail we'll learn quadratic polynomial. Okay, I said no, this is one of the most important topic in this chapter. So quadratic polynomial, we have learnt the degree is 2. One more thing, why they have written this here? Why a not equal to 0? Why this? Because if a is 0, what happens to this expression? It will become 0 plus bx plus c, nothing but bx plus c. And bx plus c is a linear polynomial, not quadratic. So the coefficient of a, or coefficient of x square, cannot be 0. That's what it means. Nothing, no big deal. Okay. What is a? Same thing, coefficient of x square. What is b? Coefficient of x. C is called constant term. Sometimes we also called a as coefficient of quadratic term. Why? Because power is 2. Power is 2 is called quadratic. Examples. See here. What is a here? A is 5. What is b here? 13. What is c here? Minus 17. C is minus 17. What about here? What about this? I have to write it here, no? 3x square plus 1 into x plus 0. Now what is my a? A is 3. What is my b? B is 1 and c is 0. Over here, check this out. Minus 12x square. There is no x term, so write plus 0x plus 2 plus 2. So what is my a, b, c? A is minus 12, b is 0 and c is 2. Simple but good to know, right? Sometimes people in boards have asked this, and actually you will not believe, they give 2-3 questions like this and they give for 2 marks. So they give that. So they'll give you expressions like this and they'll say what are the a, b, c, or the coefficient of the quadratic polynomials from the standard form. This is called as standard form of what? Quadratic polynomial. So they will say that what is the coefficient of quadratic polynomial from the standard form. They'll give you a question, write ABC, get your marks, get your answer. Come on. Next, relation between coefficients of quadratic polynomial and zeros. We'll just learn coefficient ABC. Now all the coming questions are based on this concept, most of them. Okay. So coefficients. Okay, coefficients. What are coefficients, sir? We just learned. Coefficients are a, b and c. A is for x square, b is for x and c is for just constant. Okay, so the relation that we have, and what is zeros? Zeros are the values which will make the quadratic 0. The outcome should be a big 0. Okay, so and how many will be there? Maximum of 2. For a quadratic bacha, I'll have 2 zeros. I'll have 2 0 max, right? So let's call that 0 to be alpha and beta. What are alpha, beta? Any variable like x and y. Okay, alpha, beta are variables only. So when I say sum of zeros, no, if alpha and beta are 0, sum will be a plus b. So a plus b is in terms of zeros and minus b upon a is in terms of coefficients. What is minus b? B the coefficient of x with the minus sign and a is the coefficient of x square. Next, product of 0, a into b is equal to c by a. How it is done? Okay, there is a derivation for this, but this is a short revision class. I cannot go in depth about derivation. So I am asking you, requesting you, please remember these statements for now. When we come for the regular classes, then we'll explain this. If you have doubts, put it in the comment box that sir, I want a derivation. When you come up with the classes for polynomials in detail, then we will discuss this. Okay, for now, please remember sum of the zeros are minus b by a and product of the zeros are c by a. Actually, in your NCERT, they have also given cubic polynomials, but very clearly mentioned the questions will not come on the cubic polynomial, not for the examination point of view. And what we are doing, midterm score booster. So our energy is totally to get the highest possible marks for us. It's not about 90, it's not about 100. Whatever we are, if I was getting 0 in the last exam, in this exam I'll get 50, I'll get 70. It's about me improving myself. I will get the best that I can do. How I will do that? By being with me and working hard and hard and hard with a smile. Keep a smile on your face and keep working hard. That's how we're gonna get the best version of ourselves we'll keep working, we'll keep improving. That's the ultimate goal. Not 100%, we'll keep improving everyone. Somebody who's at 99%, aim for 100, okay? But somebody who's struggling, the first day of the class, okay? What is the goal? Improvement is the goal, right? So don't get stuck in all these things. Just make sure that you are getting better every day. By how? By working hard in yourself, by playing, by having fun, by eating good food, by watching my videos. Come on. So this slide is done. Let's move on to the next questions on these concepts. Okay, we'll come back to this question. This is little bit easy question only, but it has more concepts involved in it. So we'll solve a question which is directly on that concept, sum and product. Yes, so they're asking you what? Sum of the polynomial, like find the quadratic polynomial when product is 3 and sum is -4. So write this, what I'm writing right now, write this standard form with you. Right now you note it down, okay? So whenever the sum and product is known, is given, we call sum as the letter S and product as letter P. Not standard, just because to avoid or just save some time. So how we do that from here? So the standard form of the quadratic polynomial when sum and product is given by polynomial Px, which is quadratic, equals to x square minus Sx plus P. Minus Sx is not 5, it's S. So minus Sx plus P. So what is S in this case? Check it out. What is S in this case? Sum is -4. Sum is -4. What is product? 3. So replace it. X square minus of -4 x plus 3. Answer is x square plus 4x plus 3. Understood? So very important, please remember this form of quadratic polynomial as standard form whenever the sum and product is given. Okay, let's come back to the previous question. Now this is a good question. You'll need to have attention, complete attention on the screen. You cannot do half things, you cannot write and understand. So for this slide, please put your pen down and be with me. Do not write anything, just look at the screen. Okay, all your energy over here, all your focus over here. Find the zeros of the polynomial x square plus 1 by 6x minus 2 and verify the relation of the coefficients with the zeros of the polynomial. So basically the question has two parts. First part is to find the zeros. Second part, whatever are the zeros, take the sum of the zeros, take the product of the zero and verify that with coefficients rule that we learned right now. Okay, great. So let's take the question. X square, people might think, sir, it is a fraction. So let's leave in the examination, sir. Fraction they don't ask. Even if they ask, I will lose 2 marks, no? Sir, why to do fractions? It will take time, make my head, get some headache. So let's just skip this question. Are fractions is there, we'll make it without fraction in 1 minute. How will we make without fraction? Multiply 6 on both sides, up and down. Where is up and down, sir? I will multiply 6 like this, no? 6 by 6 is 1. Make a fraction like that and write the polynomial x square plus 1 by 6x minus 2, like that. Okay, now take the numerator of 6 inside the polynomial. What I get? 1 by 6 is left here. Because the upper 6 went in, it became 6x square plus 6 into 1 by 6x minus 6 into 2. Okay, so this becomes 1 by 6, 6x square, 6 and 6 goes out, plus x minus, it's not 6x square, okay? I hope it's not confusing, but let me write it better. It is 6 into 2, okay? Not 6x square. So 6 2s are 12. Now you can factorize. No fractions inside. Don't worry about outside. Only inside we worry about. What we learned? Multiply the first and third term. No, multiply the square term and the constant term, right? So what is that? 12 into 6x square with their signs. So minus 12 6 is 72 x square. Factors of 72, 12 6, but also 9 8. I can write more factors, but let's just, I know the answer. So quickly you can try. So there can be 4 with also 4, okay? So 4 and 18 can come. So write more and more factors. 36 and 2 can come. But how can I get plus x? What x? Plus 1x from 9 and 8. If I take 9x and 8x with 9 positive and 8x negative, I will get this. So I'll write this as 1 by 6, 6x square plus 9x minus 8x minus 12. Simplify it. Take the common. What is it, sir? 6x square and 9x. So one x is common, one 3 is common. So we'll take 3x common. What is left here? 2x plus 3. Over here, what is common, sir? A negative sign is common and 4 is common. 4 into 2 is 8 and 4 into 3 is 12. So let's take 4 common. So we'll have 2x. And what is left here? Plus or minus? Plus. Pardon me, something happened. Let me erase that. Okay. Great. So 2x plus 3. Now some people will think, sir, some, very few, but they'll think, sir, how plus? How plus? How can you take minus s plus? Cross multiply, na? How can I write plus as? But I can also write plus as, minus into minus. So if I'm taking a minus common or out, what is left? One more minus sign, no? So I've taken that minus common. That's how. Okay? Or if you want an easier explanation, not this complicated, not this worrisome, then let's take, if you multiply minus with plus, what are you going to get? Back to minus. Okay? Now what is common now? 2x plus 3 is common. So take 1 by 6 outside, 2x plus 3 common. And what is left in the first term? 3x is left. So take 3x left in the first term. Second term, what is left? Minus 4. So I have the factorization now. What is the next thing? To find the zeros. After factorization, put it equal to 0. Right? That's what we're doing, no? If this is polynomial px, let's say, to find the 0, what do you used to do? Make px equals to 0. So next step, we'll do that. 1 by 6, 2x plus 3, 3x minus 4. 1 by 6, 2x plus 3 and 3x minus 4. Let me cross check if I'm right or wrong. I'm right. Okay. And we're going to do what? Make it equal to 0. How can product of two number will be 0? If one of the number is 0. So let's take first 2x plus 3 as 0 will be equal to, can 1 by 6 be 0? It's a constant, right? I can multiply on the other side. So this will be equal to 0. So what I have x equals to minus 3 by 2. Next, 3x minus 4 equal to 0, which means x equals to 4 by 3. I have the two zeros now. Let's call this to be alpha and this to be beta. What is the formula we learnt? First part is over, finding the 0. Next part is finding the sum, compare with the coefficient. Alpha plus beta. What is it? Minus 3 by 2 plus 4 by 3. Take LCM. LCM of 2 and 3 is 6. LCM of 2 and 3 is 6. We learned last class. LCM of two different prime numbers are product of the primes. So 2 into 3 is 6. So minus 2, we have to do the same operation up. So minus 3 into 3 will be minus 9. And 3 times 2 is 6. Same operation on the numerator. Plus 4 into 2, which is 8. Answer is minus 1 by 6. Okay. What about product, sir? Alpha into beta. Alpha into beta would be minus 3 by 2 times 4 by 3. Cancel 3 and 3 and 2 with this 2. What I get? Just to minus 2. Now I will write the original expression. Alpha beta is minus 2 and alpha plus beta is minus 1 by 6. Let's go back. I'll write it here. Alpha plus beta was coming as minus 1 by 6 and alpha into beta was coming as just 2. Check here. Minus 1 by 6 and minus 2. It is not just 2. Sir, don't make mistakes. It is minus 2. Okay. What is sum of the roots? Minus b by a. Minus b by a. Remember the formula, guys. If you don't know the formulas, then how can you solve the question? So keep working on the formulas. So minus b by a. What is minus b? Minus b would be, check here. If this is my, what is a, b, c? Compare here. This is the given polynomial, no? Compare here. A is 1, b is 1 by 6, c is minus 2, right? So minus b by a would be nothing but, what will be minus b by a? Yes. What is minus b by a? Minus of 1 by 6. Okay, I don't have enough space here, so I'll erase this part and we'll go back to this later. Okay. Okay. So minus of b by a will become minus of b is how much? 1 by 6. Okay. Upon a. And what is this going to become? What is a value? My a value is nothing but 1. So what is it going to become? Minus 1 by 6. Okay. So what we are doing here is, let's forget this. What we are doing here is writing minus b by a. So minus b by a is what? Minus 1 by 6, and sum of the roots is also minus 1 by 6. It means sum of the root is equal to minus b by a. For the product, take the product. What is product? C by a. What is c? Just minus 2. What is a? 1. What it is? Minus 2. And what was the product of root coming as? If you remember, AB was minus 2. Again it is equal. So sum and the product is equal to the coefficient as we compared from the formula, minus b by a and c by a. Okay, this might be little bit confusing, so I'll give this a partition. So this is the first part of the question. Second part has been done here, and the last comparison I've done here because the question was written here. Okay, let's quickly move on to the next problem. That is a good question. This we already solved. This one. Find the quadratic problems or polynomial having 0. Root 3 by 2 minus root 3 by 2. Very difficult question, sir. Extremely difficult. Not difficult at all. They are same thing. If this is a and this is minus a, what happens to the sum? What happens to the sum, sir? S, whatever it is, root 3 by 2 plus minus root 3 by 2. What is the answer? 0, na? Sum is 0. What about product, sir? Product is P. Multiply them, sir. Root 3 by 2 into minus root 3 by 2. Answer is 3 by 2 with a minus sign, because root 3 into root 3 is 3 and root 2 into root 2 is 2. I don't think this is visible, so I'll write it again. Okay. So what I'm thinking is like this. So root 3 by 2 multiplied with root 3 by 2 with a minus sign. Root 3 into root 3 numerator just 3. Root 2 into root 2 denominator just 2 with a minus sign. What is the expression? What happens whenever the sum and product is known? We just learned x square minus sum into x plus p. X square sum is 0. So this is minus 0. Product is minus 3 by 2. My expression is nothing but x square minus 3 by 2. This is my answer. That's it. Done. Okay. X square minus 3 by 2. Done. Next, the zeros of the quadratic polynomial. Okay. Options are given, sir. Is it difficult? No. but yeah, you have to use logic over here also. Thoda sa we'll use up to brain. On rest, keep it activated. So the what is given? You have to find the zeros from the given statement. Okay. Do we have to find the values of zeros? No. The relation between the zeros. Let's check. What is the sum over here? If the zeros are, let's call it to be alpha and beta, then what is sum going to be? Alpha plus beta equals to minus b by a. Sir, what is b? Likho bhai, a is 1, b is k, and c is also k. So minus b by a would be minus k by 1. Minus k by 1. What is product? Product is alpha into beta equals to c by a. What is c? K by 1. Now look carefully. They have written something very interesting here. K is greater than 0. What it means? It means it is positive. K is positive. If k is positive, then minus k would be negative and plus k would be positive. I'll repeat. How, sir? Because k is given as positive. Okay. Now think. Sum of two numbers are negative. Coming as, sum of two numbers are coming or is coming as negative, and product is positive. Sum of two numbers can be negative when both are negative. Okay. So if I have alpha and beta, let's see here. Sum is positive. Sum is, sorry, not positive, negative. Sum is negative. When can this happen? If both of them are negative, or if it is plus minus, then biggest one has to be negative, right? The biggest one has to be negative. Correct? What about product? If product is positive, means from some negative I have two situations, that either negative or plus minus only when the biggest one is minus. Okay. Product is positive. It can either be both negative or both positive. Both positive. Both has to be positive or both has to be negative. Now check out here. Both negative is placed in both conditions. Sum also okay, both negative in product also okay, but both positive. If the numbers are both positive, can their sum be negative? Think. 2 plus 5, positive number, sum is negative. I no, 2 plus 5 is 7, it's a positive number. Means cannot be both positive. This is my answer. Both numbers cannot be positive. For the sum to be negative, one of the number has to be negative. And which number? The biggest one. I hope it's clear. Okay. From the given condition where k is given positive, we reached to the situation that sum is negative, means either both negative or one positive negative. Product means positive, means both negative or both positive. Both positive, if I take product, then the sum cannot be negative, which is not true. In that case, the both roots cannot be, or both zeros cannot be positive. Moving on. The sum of the zeros of the quadratic polynomial is equal to the product. Now, so what they are saying is, if the zeros are alpha and beta, so they are saying that alpha plus beta is equal to alpha beta. Okay. So what it means, or whatever it means, we'll find the value of alpha plus beta now first. We'll see whatever it means later. Whatever we know, we'll do that first. Maybe some way or some path will come out of that. So what is alpha plus beta? Let's find it here. Alpha plus beta. What is it? Minus d by a. Quickly, come on, be with me. Minus d by a is b. What is this? This is my a, this is my b, this is my c. b by a means minus 2 by k. Minus 2 by k, correct? Okay. What about alpha into beta? Alpha into beta will be c by a. What is c? 3k. Just 3 we will take. No sir. We'll take full 3k. Full 3k is my c. K is a variable, but it is a constant in this case. So 3k by a. A is what? k. I'll write k here, cancel it, becomes 3. 3k by k is 3. Okay sir. Product and sum we have found out. Now in the question, they are equal. Alright, so we make it equal. Minus 2 by k is equal to 3. K there, 3 here, it becomes k equal to minus 2 by 3. And what are they asking? Find the value of k. Such a simple question they gave after solving that fraction wala question. Arey, all the questions are simple. None of them are difficult, right? Okay, very simple. The sum was given equal to product. We found the sum. We found the product. Made them equal. Found the k. End of the question. Moving on. Come on. Okay. Sir, it's scary. Too many variables, sir. Whenever I don't see numbers, no, sir, in the questions become very difficult. No, sir. Variables means no calculation, no. Easy. Variables means no calculation. Simple steps, formula, concept and done. Question is over. Variables are easy. But you should know the concept. Okay. Come on. A quadratic polynomial whose zeros are. So we don't know the quadratic polynomial. Reciprocal of zeros of quadratic polynomial. So this statement is such a tongue twister. Quadratic polynomial whose zeros are. Reciprocal of zeros of the quadratic polynomial. Arey? Sir, I got lost here only. Don't worry. You got lost here. Let's start from the second statement. Quadratic polynomial from here. Zeros of the quadratic polynomial ax square plus bx plus c. Sir, why they have written a not equal to 0? Because if it a is 0, then this will not be quadratic, it will become linear polynomial bx plus c. A is 0 means whole term is 0. Okay? Alright, sir. Why c not equal to 0, sir? We will know right now after solving the question. You ask me the same question, why c not equal to 0? I will answer this after solving the question. Okay? Right now, why a is not equal to 0? Okay. So far we have decoded that something has to do with zeros of the quadratic polynomial. So sir, I know zeros, too many words. Let's make some variables and get the work done. Let's say the zero of this polynomial is alpha and beta. Now what we have actually done is, we have gotten rid of the last statement. So I can just say, instead of all this line, I can write just alpha beta, because zeros means what? Alpha beta. Now read the question. A quadratic polynomial whose zeros are reciprocal of what? Alpha beta. What is it? The quadratic polynomial which we do not know, their zeros are reciprocal of alpha beta. It means if the alpha beta are these zeros, then for the unknown quadratic polynomial, let's say that is fx, we don't know this polynomial, the zeros are 1 by alpha and 1 by beta. Now question is easy. We replace the second statement by alpha beta. So the reciprocal of alpha beta is 1 by alpha, 1 by beta. Hope this is clear. I've tried my best. Okay. So quadratic polynomial fx we don't know. That zeros of fx are reciprocal of the zeros of the second polynomial, which is alpha beta. So 1 by alpha, 1 by beta. If we know the polynomial, this is alpha beta, let's just put a stop. This is just to understand the question. Now coming back to the question. What is the question given? Ax square plus bx plus c. Quickly find me sum of the roots. Alpha plus beta is how much, sir? Sir, minus b by a. This is standard form. How can you even ask, sir? This is standard form. There's no need to ask this question, right? Excellent. And alpha beta would be c by a. Alpha beta would be c by a. Okay, sir. So how does it help us? It will help us. We know sum and product for the known polynomial. What about unknown polynomial? What about unknown polynomial? So whatever is the unknown polynomial, we know the roots now. Sir, how, sir? Because they are reciprocal. So 1 by alpha plus 1 by beta. So if we know the roots, it means I can find the sum. So I'll write here sum of zeros of unknown, okay, unknown quadratic polynomial, which is also given here as, I have taken here as fx. What is UQP? Unknown quadratic polynomial, which is asked in the question, fx. is given by 1 by alpha plus 1 by beta. What is 1? This is going to be LCM is alpha beta. This is beta plus alpha. I can write this as alpha plus beta upon alpha beta. This is sum, so I can write this as capital S. Sum of alpha plus beta, we got it as minus b by a. Minus b by a. And product, we got it as c by a. Right here. So minus b by a. How, sir? Because we got. And c by a we got here. Cancel a and a. Cancel a and a. What is my answer? Minus b by c. Now you say c is not equal to 0. We had that. C is not equal to 0. If c is 0, the denominator will become equal to 0. Everything is undefined. Infinity. How will you go? That's why c is not equal to 0. They have given in the question. Now sum we found out. Let's go to the product. Let's go to the product. So what again we'll do? Product of zeros of what? Again fx, which is unknown polynomial. What is it going to be? 1 by alpha into 1 by beta equals to 1 by alpha beta equals to what? 1 by alpha beta is c by a, which will become a by c. A by c. So now we have sum and product of unknown polynomial known. What is the expression that we know? Formula we learned, fx equals to x square minus s times, s is the sum, times of x plus p. Write x square as it is. But we do not know the coefficient, okay? What value it can be. So let's go here. S is what? Minus b by c times x. What is p? P is a by c. C is common in the denominator. Let's multiply everything with c. We get it as cx square plus bx plus a. Right? Because if you multiply everything with c, are you missing this step? Is it making this confusing? Everything you did easy, sir. Last step, why are you making it difficult? I know. My students, don't worry. I'll do it in a simpler way. Okay. चलिए यहाँ से then little give me this attention over here. So multiply everything by cc. So I'll get c here, and this will become x square minus. So this will become plus, no, minus is plus. So plus b by c x plus a by c. The numerator c you take it in. What will become? This is equal to, okay. So I'll take one c outside, and this will become c x square plus b into b by c into b by c is what? Just b. C into b a by c is what? Just a. Now don't say, sir, how? Is this c and this c will get cancelled? No, if you multiply this c over here, it becomes cx square. If you multiply this c over here, it becomes c into b into c. So just b. If you multiply the same c over here, c into a by c, c will get out. What is left? Just a. Okay. Now, so this is my answer. Now compare. This is what? My fx. They were asking us to find the polynomial. Let's go back to the question. The polynomial is given by, compare here, what is given? Cx square plus bx plus a. 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 Sir, you got this as 1 by c, and here it is k, sir. That is a constant, na? I can write 1 by c as k. Any problem, huh? I can write 1 by 2 as 0.5. So my k will be 0.5. 1 by c is k, no problem. I can take any variable in place of any variable. Okay? I hope this is clear. So what is my answer, sir? My answer is B, sir. My answer is B, sir. Cx square plus bx plus a. The main part is the what is inside. Cx square plus bx plus a. How we did it? For this given expression, we took the zeros to be alpha beta. They said it is reciprocal. We took 1 by alpha beta. From the given expression, we found the sum product. Use the sum product of 1 by alpha beta to find the ultimate required expression. Question done. Good question. Challenging. So make sure you solve it once or twice if you're not getting it. You have the solutions here. On our channel, you will get the link for the description to solve your, to get your solutions or of the notes you'll get your homework questions. So visit visit the description link and make sure you get the PDFs. Okay, great. All right. So now over here, if alpha and beta are the zeros of the quadratic polynomial, fx equals to x square minus 1, find a quadratic polynomial whose zeros are 2 alpha by beta and 2 beta by alpha. 2 alpha by beta and 2 alpha by beta. 2 beta by alpha and 2 alpha by beta. कैसे करेंगे? How will we do it, sir? Find the zeros. Don't get complicated. Make it easy. Make it easiest. Polynomial is given, sir. fx equals to x square minus 1, sir. How do we find 0? Put it equal to 0. X square minus 1 equal to 0, sir. Factorize it. X minus 1 times x plus 1 equal to 0, sir. How, sir? Because x square minus 1 square equals to x minus 1 into x plus 1, right? Put them individually equal to 0. X equals to 1, x equals to minus 1. Alpha and beta are the roots. Let's take alpha equals to 1, beta equals to minus 1. Now find the roots given. First root is 2 alpha by beta. 2 alpha by beta. What is this? 2 times of 1 by minus 1. What's the value? Minus 2. Next one, 2 beta by alpha will come the same. 2 times of minus 1 by 1. Answer is minus 2. Now what happens here? What are these? These are the roots only, no? Or the zeros only, right? These are the zeros. Okay, let's say this is 0 number 1, 0 number 2. Now if I find the sum of the zeros, if I find what? Sum of the zeros. Sum of zeros. What is it given by? Letter S. Take these two sum. What is sum of these two going to be? Minus 2, minus 2. What is the answer? Plus 4. What is the product going to be? Product going to be, sir, P equals to minus 2 into minus 2 equals to plus 4. Sum and product you know. Find the quadratic polynomial. X square minus sum times of x plus product x square minus of sum is what? I forgot, sorry, a minus sign. A minus sign is there. So minus of 4 times of x plus 4. Answer is x square plus 4x plus 4. This is my final answer. X square plus 4x plus 4 is the final quadratic polynomial they are asking. So find the quadratic polynomial where the roots are 2 alpha beta and 2 beta by alpha. They gave a polynomial, we found the roots, we used that alpha beta to find our new roots. Sum we found, and we found the product and as well, and then we found using the standard form of quadratic polynomial. Okay, let's move on. Okay, now this is a challenging question. This is a question of good level. You need a very good understanding of algebra, factorization and the identities to solve this question. We'll see. Okay, now they're saying that if alpha and beta are zeros of some quadratic polynomial, okay, where the sum is 24 and the product is 8, find the quadratic polynomial whose zeros are alpha and beta. So we all know to find any quadratic polynomial we need what? X square minus sum times of x plus p. Means I will require sum and the product. So if alpha and beta are the roots, so I need alpha plus beta, but I also need alpha into beta. Alpha plus beta is given. Life is easy. But alpha into beta is not given. We have to find that part. How will I find that part, sir? Okay. Remember this formula? First I will write in terms of the value that you remember. You remember A and B, I guess. So you remember this A, same thing, come on. Alpha has become a habit now. So let's erase this and write in terms of A. Okay. A plus B whole square. What is it, sir? A square plus B square plus 2ab. Now I will write directly in the form of what? Alpha and beta. Check it out. So alpha plus beta ka whole square will be alpha square plus beta square plus 2 alpha and beta. What about alpha minus beta ka whole square? Alpha square plus beta square minus 2 alpha beta. If this is my equation 1 bacha, and this is my equation 2, can I subtract it? I can subtract it. Subtract it. Minus sign here, sign change, minus sign here, plus sign here. What's this side gonna be? It's gonna be alpha plus beta whole square minus alpha minus beta whole square. And this side what will have? Go out, go out, go out, go out. What about this? Plus 4 alpha beta. So somehow using the sum and product we have reached. Using the sum and difference we have reached the product. Okay, sum we know 24 is 24 square. Difference is 8 minus 8 square is equal to 4 alpha beta. A square minus b square, apply it. 24 minus 8, 24 plus 8. 24 plus 8. Now this 4 is a constant. I can take it on the denominator as 4 equals to alpha beta. Alpha beta. Okay, I'll write it over here just to carry on with our calculation. So 24 minus 8 is how much? 16. 24 minus 8 is 16. And 24 plus 8 is 32. 32 divided by 4 equals to alpha into beta. Cancel 4 and 32. 4 8s are 32. Right? 4 not visible. Pardon me. I'll make it visible for you. 4 8s are 32. What do we have now? Alpha into beta equals to 16 into 8. What is it? 8 6 are 48. In hand 4. 8 plus 1. 8 into 1. That's the answer. Right? 16 into 8 is 128. Now we know the product. We know the sum. Where we know the sum? 24. So I can write this final answer over here. X square minus sum times of x plus p. So x square minus 24x plus p. So 128, and this is my final answer. I hope you understood it. Everyone, please say yes in the comment. Okay, for the question, this question, alpha plus beta and alpha minus beta. Okay, I hope you understood. So sum was given, difference was given. We had to find the product. We used the identity to find the product, and then we use the standard form of quadratic polynomial when the sum and product is known. Excellent. So what happens, children, is like right now your 10th are coming. Now you might be confused what to do after 10th grade. How to start up, what to think. Science is better, commerce is better, bio is better, maths is better. What is good for me? How would I know my potential? Because you all are children, right? You will not know everything from day one. So what you have to do is, don't worry, we have come up with DSAT. It's Diksha Scholastic Aptitude Test. What you have to do is visit our nearest center. Okay, go there, take this test. In this test, you'll have a lecture given by a faculty for 60 minutes. Based upon the lecture, you'll be given a aptitude test. Then it will be graded. Upon your score, you can discuss with our mentor there. You can have the counseling done one by one with your parents. Okay, and one more thing, apart from all of these, like you can write the DSAT, do the counseling. If you are good, if you're looking to get enrolled with us for 11th grade in the coming year for any physics stream, PCM stream or PCB stream, based upon your DSAT score, you'll get scholarship up to 90%. Okay, so what are you waiting for? get enrolled with us, contact our nearest center. Alright, great. Now, the last and the most important slide, the homework questions. So we have done all the varieties of questions, bacha. Everything we have done, difficult kind, very simple kind, definition based, every type of questions we have discussed today, right? Every type of questions. So this covers almost everything in your chapter which is going to come for your midterm portions or your finals. If you revise it properly right now, it'll be ready with you. Just have to do a quick revision at the time of finals, okay? So what you have to do right now, solve these homework questions. Solutions you'll get where? First try yourself, give it an honest try, because why are you here? You are here to learn something, okay? So give it your honest try by yourself first. It's okay to make mistakes. Whatever you know, you try first. Then you go to our description box, find the link there, go to the web page, get the PDF form of the class notes, get the solutions there, and you will be able to solve the questions by looking at the reference. If you got it wrong, but then you will know, okay, I got this wrong, this step I got wrong. Then you would have thought, now while solving a question, you think, you use your brain. So then you will be able to correct your wrong steps. So make sure that you give it an honest try before using the solution of the homework. Let me just quickly explain you the questions so that it will be easier for you to give your try. Find the zeros of the following quadratic polynomials. Verify the relationship. Arey, this is given. Factorize kar lenge. Factorize this. Get the roots and use the formula minus b by a, c by a to compare the coefficient and say it is verified. Okay. First one is simplest question ever. Okay, this is 2 and this is 3. Okay, question number 2. Alpha, beta are the zeros of the quadratic polynomial. So do one thing. This question we did right now. Find the alpha, beta, find the sum from here, and product from here, and this. You have to find it what? What is this going to be? Alpha plus beta by alpha, beta. So whatever sum and product you're finding here, use there. Okay, last one, I'll erase this. I don't want to take this as hint. Just use your own learnings. Come on. Okay, so last part. If a and b are the zeros of the quadratic polynomial, fx equals to x square minus 2x plus 3, find the polynomial whose roots are a plus 2, b plus 2. This is a good question. So how will you solve it? Find the relation of sum of the roots and product of the roots from here, and from there you use this to substitute in the question. Use your brain. If you don't get it, you'll have the solution to solve it. Okay, this concludes our session for today. What we are doing right now, we are coming with a series. Every day you'll get a session on your chapters coming for your midterms. Okay, we have this week over series. So every day for maths you join on Diksha Vedantu Foundation channel. Be here. You will always get these videos. Everything will be discussed in the class, all the important questions, all the PYQs. So, and with the concepts, I will not forget the concept, because I might miss a question. I might not be able to tell you exactly the question which is coming in the exam, okay? But I can tell you the concept which is going to be used to solve that question. So I will not miss any concept, even if I miss a question, but that is also very difficult because I am doing my research before coming for the class. So I am not missing any questions, but even if I miss a question, I can make a mistake, but I will not miss any concept. So make sure that you are here with us, going through our video, learning everything, and finishing your chapter, giving a thumbs up that yes sir, we have understood the chapter today, which is polynomials, and we will meet in the coming session for the third chapter. Okay, so take care of yourself, take care of your health, study very, very, very hard, do the hard work, keep smiling. See you in the next video. Thank you. I am Ankit Sir signing off. Bye.